Hello students, today we are going to discuss the topic the necessary and sufficient condition for existence of solution for a non-homogeneous system Ax is equal to B. The system Ax is equal to B of non-homogeneous linear equations has a solution if and only if rank of A is equal to rank of A by B. There are two parts in the theorem. Let us see the first part, that is direct part. Suppose the system of non-homogeneous linear equations Ax is equal to B has a solution. Say x is equal to alpha 1 alpha to alpha n. That is, these alpha 1 alpha to alpha n ordered n tuple satisfies the given equation Ax is equal to B. This implies that A into x is equal to B. We have already know that this A can be written as C1, C2 and so on Cn, where C1, C2, Cn are n columns of this matrix A and x is equal to this alpha 1 alpha to alpha n. This is a column vector is equal to B. This implies that alpha 1 C1 plus alpha 2 C2 and so on alpha and Cn is equal to B. This implies that B belongs to a linear span of, that is, this B can be expressed as a linear combination of C1 C2 Cn. So B belongs to linear span of C1 C2 Cn. This implies that linear span of C1 C2 Cn is equal to linear span of C1 C2 Cn comma B. This implies that the space generated by C1 C2 Cn is equal to space generated by C1 C2 Cn comma B. This implies that column space of A is equal to space generated by columns of A and the one more vector B. So dimension of column space of A is equal to dimension of space generated by C1 C2 Cn and this vector column vector B. This implies that the column rank of A is equal to dimension of the linear span of, that is, the space generated by C1 C2 Cn comma B. This implies that column rank of A is nothing but the rank of A is equal to rank of A by B. Dimension of C1 C2 Cn means this is A and comma new column B. So this is nothing but the rank of A by B or A comma B. So we have proved that if a system is consistent, that is Ax equal to B has a solution, then we must have rank of A is equal to rank of A by B. Conversely, suppose that rank of A is equal to rank of A by B, let R is equal to rank of A equal to rank of A by B. Therefore, the column rank of A is equal to R. Therefore, the R columns are linearly independent. Suppose these R columns are Ci1, Ci2, Cir are linearly independent. What is I1, I2, IR here? I1, I2, IR be any R numbers from the set 1 to n, where these I1, I2 and so on IR belongs to the set 1, 2 and so on n. We don't know which columns are linearly independent. Okay. So now if possible, suppose B does not belongs to the linear span of Ci1, Ci2 and so on Cir. Okay, so this implies that the factors, which vectors? The vectors Ci1, Ci2 and so on, Cir, B are linearly independent. So this implies that rank of A, B is, these are linearly independent. This is greater than or equal to R plus 1. This must be greater than or equal to R plus 1. And these are R plus 1 in number. So rank of A by B is greater than or equal to R plus 1. So this implies that rank of A is greater than or equal to R plus 1, because rank of A equal to rank of A by B. This implies that R is greater than or equal to R plus 1, which is a contradiction. Hence the vector capital B must belongs to the linear span of ci1, ci2 and so on, cir. This implies that B must belongs to a linear span of C1, C2 and so on, Cn. This implies that exist scalars beta 1, beta 2 and so on, beta n belongs to R such that beta 1 C1 plus beta 2 C2 plus and so on plus beta n Cn is equal to, this implies that x is equal to the column vector beta 1, beta 2 and so on beta n is a solution of Ax equal to B. Thank you, students.